as we get rolling with the height equation, again, we're going to round out our answers to their hundreds, so we're not going to see many whole numbers today. We chatted about this first one quickly the other time, but again, this isn't going to be something that's real bad. When an object is dropped, notice dropped, not thrown, not tossed, not heaved, not anything, just dropped. I just let gravity do its thing. Okay, its speed continually increases and the height above the ground is decreased faster and faster. So the higher up you are, you drop something, the faster and faster it's going to go before it hits whatever it's going to hit. The height of the object t seconds after it drops can be modeled by this function. Okay, so here's my thing with this. The biggest thing you need to take from this is this h sub o thing is where your object is starting from. Okay, I'm on top of the roof. It's coming out of my hand, 6 feet above the ground, whatever it is. This h, capital H, is where your object ends up at the end. Normally, that ends up being 0. Like if it says hits the ground, drops, whatever. We're going to assume it's 0 unless we're told otherwise. So, the negative 16 is just the gravity factor when we're talking in feet. When we talk in other measurements, that'll come a little later. So, again, this model only works on Earth. So if the problem's about Mars, don't use... Just kidding. We're not going to do that. So, Niagara Falls in New York is 167 feet high. All right, that's where we'd be starting. That's our H sub O. How long does it take for water to fall from the top to the bottom? Okay, we can't go lower than the bottom. Well, I guess you could technically, but so that'd be 0. So here is my equation. Here's where you have a choice. If you don't have a t term in the middle, you can treat it like we would x. You can do this algebraically if you wanted to. You could be like, okay, I could minus the 167 out. Don't take the square root yet. Don't do it. I can divide by negative 16. And then I could just come here and be like, all right, so the square root, because that would be the next step anyway, of 167 divided by 16 is 3.23. Now, some of you may be going, Hardy, you're breaking rules of solving by roots. Isn't it plus minus? Now, again, remember, this is an application problem. Would negative 3 seconds make sense? Hi, I fell off the top of Niagara Falls and I hit the bottom 3 seconds ago. Not really. So here, we're just going to have the positive. That's the only one that makes sense. So I can go algebra, or I can take this part of my equation, put it into the y equals of my calculator. If I type it in right, let's try again. But I have to be able to understand what I'm looking for. Here, the bottom of Niagara Falls, here's the bottom. This bottom is finding the x-intercept. It's finding the 0. The x-intercept's like the ground, okay? The x-axis. So here, I want to know what that is. Well, Hardy, what about that? That's negative time. That makes no sense. I want this one. Second trace 0. Let's actually get that in here. Second trace 0. That's going to get me my intercept. So we're like, oh, it's that bound thing again. Okay, we've done this. Hardy, where's the cursor? Okay, we got to use the info we've got here. It looks like, and we kind of know, this is just past 3. Right now, x is at 0. So I got to go to the right to get closer to where 3 is. But also notice the y value keeps coming down. Now, pretty soon here, it's going to show back up. There we go. Oop, there it went again. Okay, that's as close as I'm going to get. That's okay. As long as I'm in the screen, That's where will be my starting point. And this was the part when we got as close as we could that we did the left arrow. It says left right there. 1, 2, 3. Enter to make my boundary. I know my cursor disappeared. It's okay. Hit my right arrow to get back where I started. And then the question changed. Now it's right bound. So I'm going to do the right arrow. 2, 3. Enter. If I've done it right, those arrows should be pointing in at each other like, I'm going to find you. There it is. Hit enter for my guess. There's the same 3.23 I got with algebra. So we're just finding the 0. Okay, and we've done that before. It's just making sure we can figure that out from the problem. So that's going to be the main gist of all of these. And as we get further in, I'm not going to have to spend all this time explaining. We're just going to be doing. So let's see what else we got here. Tennis ball dropped from a height of 213 feet. How long does it take for the ball to hit the ground? Same idea. There's my start. There's my end. Totally up to you if you go algebra or you go, and I didn't even mention, you could do the quadratic formula on that too if you wanted to. That's an option. So again, here, your call. If you go algebra, that's cool. If you go calculator, let's see what we got here. That one doesn't make sense. That one does, though. Second trace 0. And here we go again. It's somewhere between 3 and 4. So I'm just going to watch my X here. I'm going to get between 3 and 4. Oh, there it is. Okay. Just got to be in the ballpark on the screen. Left. Left. 1, 2, 3. Enter. My first boundary. Right. Got to get back where I started first, though. Arrows pointing in. We found our target. Bam. 3.65. So as you're doing these, again, this will tell you a whole lot. Now here comes our twist problem with these. Stuntman working on the set of a movie is to fall out of a window 100 feet above the ground. Okay, so there's my starting point. There's my H sub O. For the stuntman's safety, an air cushion 26 feet wide by 30 feet long by 9 feet high is positioned on the ground below the window. How many seconds will the stuntman fall before hitting the cushion? Hopefully not the ground. That would hurt. What's my capital H going to equal this time? 9. The other stuff is in there just to try and confuse you. So there is one part of this, though, that I have to be careful of. And that is, before you put it in the calculator, that 9 can't be there. This has to be equal 0, sort of like what we talked about before. So subtract that 9 over to here. Now it's the exact same problem again. Yeah. Yeah, if you're doing it algebraically, subtract that over and go. Absolutely. Well, let's see what I do when I go calculator here. Let's see if... All right, stuntman, definitely not negative unless you're in the matrix. So looks like we're between, what, 2 and 3? Second trace 0. All right, let's see here. Somewhere between 2 and 3. Okay. We're close. Left. Move this up just a little bit so people can see my button presses. 1, 2, 3. Enter. There's my boundary. 1, 2, 3. Back where I started. Right. 1, 2, 3. Enter. We've zoned in. I'm getting 2.38. Yeah. I have people with agreements. So we even get a bonus piece this time. I can keep the bonus. A movie camera operating at 254 frames per second records the fall. How many frames of film show the stuntman falling? Okay. Well, if it's 254 frames per second, and this was rolling for 2.38 seconds, let's see here.
How do we know that it was? Oh, because the top one.
Yeah, the first part got us here. Now, here's where we got to use our common sense a little. So we get 604.52, but you don't want to be watching the film and the film cuts off because you only had half a frame. So we got to round up here or everybody's going to be left in suspense on if the stuntman actually hit the spot he was supposed to or he just splatted all over the ground. Well, if we round down, we're going to lose that last 0.52 of what we were doing. Right, that's why I got to make sure I'm only going to use half of that last frame, but I still got to use the whole thing. So if I go to 604, I lost that last millisecond of my man falling. Is that one of those things, so like on a quiz, I'm going to go, no, 604. If it's 604, 605, I know you did the right thing. So those are all, again, though, we're dropping. We're just falling or just letting go of something. However, sometimes things don't just fall. Sometimes they get launched, they get thrown, like me talking about the other day, erasers, we chuck them, okay? If you see something is launched or thrown, now we add an extra piece to the puzzle. Initial velocity. How fast is it coming out of my hand, out of the, whatever it happens to be. Everything else is the same. So you could, if you wanted to one-stop shop, you could use this formula for both dropped and launched. Because if you dropped it, if V sub O was 0, if you dropped it, 0t would just go away, and you're back to the same thing. So just something to consider if you want less things to have to try and think about. Hardy, please tell us you're at least going to be nice and give us like this part on the quiz. Yes, I am. Okay, you've got my word on film now. These basic equations will be there, yes. You just got to know what to plug in. So, okay, baton twirler. Let's do this. Tosses a baton into the air. The baton leaves the twirler's hand 6 feet above the ground. All right, there's where we're starting. Has an initial velocity of 45 feet per second. There's my V sub O. The twirler catches the baton when it falls back to a height of 5 feet. End point, H. How long's the baton in the air? So if you have to kind of think about a picture, it goes up, and then it comes back down to where you were. You're still looking for the 0. So 5 equals negative 16t squared plus 45. Don't lose the t. There is a t there with your V sub O. Plus 6. Still got to have this equal 0, no matter what route you're going to go here. So Hardy, what choices have we got this time? You have 2. Find the 0 on the calc like we've been doing. Use the quadratic formula. They both work. Factoring that, good luck. Don't want to do that. Don't want to do that. We can't just solve by roots because there's a t term now. So the narrative's changed a little bit. So it's your call. I have a feeling since you've been doing calculator, a lot of you are going to go that way, but I'm going to go quadratic this time because that's the new piece of the puzzle. So here's A, here's B, here's C. So opposite of B plus or minus the square root of B squared minus 4AC all over 2a. And I'm going to give the same advice I did yesterday when we did quadratic formula. Do not try and do this entire thing on your calculator at once. It will become a disaster. All I'm going to do, I'm not even going to put all this stuff under the radical right now. I'm just going to do that. I'm just going to do this piece right here. Then I'm going to take the square root. So I've got negative 45 plus or minus 45.7 over negative 32. Now, remember, one of these answers is not going to be sensible. I only want the one that's sensible. So let's try this out. Negative 45 plus 45.7 divided by negative 32 is a negative. Okay, that makes no sense. That isn't going to work. So let's try the other one. Negative 45 minus 45.7 divided by negative 32. That's reasonable. But here's the thing. Here's the one downfall to the quadratic formula if you're going to the calculator, because you're going to have to remember this. Notice when I did my calculations on here, I did my numerator first, I hit enter, and then I divided by negative 32. Why did I do that? Because here's what people forget every time when they're doing this. I see it, they'll do this, and then they'll be like, Hardy, it took negative 43 seconds. I'm getting all these negatives. Because your calculator is going to do the division first. You've got to use parentheses if you want to do it all at once, or you need to do it in pieces, or it's going to mess up. Yes, sir?
Wouldn't A be negative 16? And then, like, for the...
A would be negative 16, yes.
Well, they put in the O to C is 1 now.
Yes. Yes, that's why we've got to get that 0 to make sure. But again, every problem we've done so far, you can find the 0 on the calculator if you want to go that route. It's an option. Okay. I'm going to leave 6 for a moment because I want to make sure that we're giving everything its just due, because 6 is really similar to 5. So give us a moment here. It's a moment. And we will be back. Because there's a twist about to come our way. Because life has them every day. That's why. You just want the same old boring thing. You want Groundhog Day like every day. It's just the same thing. Old.
What is Groundhog Day?
Negative 45 minus 45. Yeah, just make sure to do those in pieces. Because otherwise stuff can get a little crazy. Okay, let's go to tennis. You and your friend are playing tennis. Your friend lobs the ball high into the air, hitting it when it is 3 feet above the court. Okay, so there's our H sub O. With an initial velocity of 40 feet per second. 40 feet, not 40 feet. 40 feet per second. V sub O. You back up and prepare to hit an overhead smash to win the point. To win the point, the ball has to hit the ground. So H is 0. So we got to put a little context in sometimes. Write an equation giving the height of the lob tennis ball as a function of time. What the heck does that mean? All this means is your variable is going to be t and not x. Otherwise, we're doing just what we've been doing. So we're like, all right, we got gravity. Gravity has not changed. We've got our initial velocity. Don't forget the t. We got our original height. And we know where we're going. Now, technically, would I make this y probably instead of 0? Yes, but we know what we're looking for. So I'm not going to worry about it too much. Here comes the twist. At what time does the ball reach its maximum height above the court? At what time? Time is always x. So you're like, wait, So right here, I need to know what the x value of the vertex is. I do. And I'm going to look ahead slightly. What is the maximum height? Height is y. And if you think about it, that makes sense because y goes up and down. So basically, we need to calculate the vertex of this. Now, do we have options? Yeah. We have lots of options. Could I do it on the calculator with zoom fit? Sure. Could I, since we have a new twist, can I use algebra? Absolutely. The opposite of b over 2a, let's see here. Negative 40 divided by negative 32. 1.25 seconds. And now the world just opened up to me as far as options go. Well, how do I want to get y? I don't know. Do I want to just plug in y for the t's and be done? Maybe. Let's see here.
X is now T.
Yeah, because we're talking about time, so they use t instead.
X and T.
Yep. So there it was straight algebra. That's all I did. What if I don't want to do that? Okay. Let's not do that. Let's do what we've been doing. Except, remember, this time we're looking for the top. We're looking for the max. Well, I can't see the max, Hardy. Okay. Zoom. Zoom fit. Help us out, calculator. Here we go. There it is. Just remember, when you go to do your second trace, we're not looking for 0 anymore. We're looking for max. And so we're going to try and get as close to that max as we think we can. We don't have to be perfect. And once we're there, follow the directions. Left bound, left arrow. 1, 2, 3. Enter. Get back to where we started. 1, 2, 3. And 3 more. 1, 2, 3. Check that out. Maximum. X is 1.25. Y is 28. 53. Well, I got part of it right, the 5. Okay, so let's see. If you plan to hit the smash when the ball falls to a height of 8 feet above the court, how long do you have to prepare for the shot? Okay, what changed? The end changed. Because it's not getting to the ground now. I'm going to smash this thing down when it's 8 feet above the court. So, that 0 just became 8. Now, what just changed, though? Well, first, that has to be 0. We know that. But am I still looking for the vertex? Not anymore. We're hitting the smash. We're back looking for the 0. How long is it going to take for that ball, or for me to prepare for that shot? So again, here come your choices. Do I go quadratic formula? Do I go back to the well with my calculator? That's your call. I'm going to go back to Zoom Standard, though. And I got to change my equation here. Told you, this is going to be a little bit of a chunker of a -5 instead. Everything else is the same. So let's take a peek. That one. That's what I want. Second trace 0. The calculator is great for these if I know my button presses. All right, that's close enough. And again, we're trapping the 0. Left. 1, 2, 3. Enter. Back where I started. 1, 2, 3. And to the right. 1, 2, 3. Boundary is set. Bam. 2.37 seconds. Makes sense. Last large twist. Then something went wrong with your calculation. I don't know if you forgot to put a minus, if you forgot parentheses somewhere, if you didn't put a negative, you know, into your A value. I'm not sure.
Negative 16 times 2 is negative 62.
Let's see. So we got 40 squared minus 4 times negative 16 times negative 5. So, yeah, somewhere a minus or a negative got lost, is what I'm assuming. Now, if I take the square root of that, yeah, we still aren't in the same place, but yeah, you're gonna get one negative and one positive with that, for sure. So we'll have to take a peek in a bit and see where the twist came in. Okay, last one. Because all I got to do in the bottom is explain one detail. We don't have to go crazy with all this. Suppose you hit the smash when the ball is 8 feet above the court. You're like, okay, Hardy, I'm getting tired. So that's the initial spot. The ball's up there. Whoop, there's my initial height, 8 feet above the court. It takes 1/10 of a second for the ball you smashed to hit the court on your front side of the net. Woo, this thing got some heat, okay? So, that's T. Ooh. And then to hit the court on your friend's side of the net, so H is 0. What's the ball's initial vertical velocity coming off your racket? Okay. Let's start filling in. End value is 0. It's hitting the court. Gravity is still here. But this time I have a T value. So I'm actually going to plug that in whenever I have a T. So negative 16 times 1/10 squared plus 1/10, because there's still a T in my middle term, but I don't know what V sub 0 is. So here's my variable now. Plus 8. You're like, what the? How the heck are we going to solve this? Pretty easy, actually. Because if I take my calculator, I'm not going to the graphing part this time. I don't think we need it. So I've got negative 0.16, no variable, plus 0.1 V. I'm just going to leave it as V for right now, plus 8. So if I do 8 minus, I guess, 0.16. So 0 is 7.84 plus 0.1 V. That's a regular two-step equation. Okay, I don't have to get cute. I don't have to use the quadratic formula. I don't have to take roots. I don't have to do nothing fancy. And this is going to be our last mind brain blow, I believe, of the day. But you don't multiply them first and then square it. You're squaring the 0.1 and then you're multiplying it by negative 16. Can you have negative initial velocity? Yes. Because if you think about it, if you're hitting a smash in tennis, that ball is coming at you and then you're sending it back where it came from. But fast. Negative 78.4 feet per second. Hope your friend's paying attention over there. You can end up with some big problems. So that's what we're doing with those. If we're spending an entire period setting them up, oh, you mean like with that much depth and that many pieces? Probably not this many pieces, no. Okay, here's the only thing. I'm not going to drive you crazy through more pages of notes. I just want you to make note of one thing. If the measurement that you're using changes. Everything we've done has been in feet. The only difference if the word meters comes into play, okay, our European friends here, some of our Canadian friends, gravity value changes because a meter is not the same size as a foot. So the only thing you need to keep track of here is the difference between is it meters or is it feet for that first number. Everything else we've done is the same. There are no other twists. So to give you a little bit of a heads up as to what this will look like when you get it on the quiz, for the actual practice at the top of it, it talks about feet, meters, and it's going to look like this. All you're going to need to do is figure out, okay, this is this, plug this in, and go. So here's what I'm going to do. I still would tell you to work on odds, okay? What I'm going to do after advisory is over, I'm going to go down and I'm going to make a PDF of the entire key and I'm going to post it. So that way you can see exactly, okay, how did I set up the equation? Yeah, I did that right. Which thing am I looking for? So you can see all of it. Do not use it to go the easy way out and copy. It will kill you on Wednesday. If you're using it the right way, it's going to be helpful. So I'll have videos going up, I'll have keys going up, trying to make sure that we can ask